I saw the radar signal come up on my scope. I saw all my sensors pick it up. And immediately the system put a jamming package on it. I saw the jamming package cover the signal and then immediately walk it off the scope in under a second. And it was just gone. And then the signal would come back up and they would try to find me again and it would walk it right off again.
How is your pulse at this moment? I mean,
so honestly, the jamming happened, the countermeasures happened so fast that by the time I realized that I should be scared, it was already dealt with.
What would have happened if your systems didn't work? Hello and welcome to Allies in Innovation. I'm Mikkel Svold, and today we are talking about something you can't touch, you can't see it, but you absolutely need to have control of it if you want to win a battle, if you want to win a war. We are talking about the electromagnetic spectrum dominance, that is. Because modern warfare doesn't really start with the pull of a trigger. It starts in the spectrum. It starts with sensing, jamming, deceiving, protecting, integrating, all this. It's basically radars versus radars and networks versus networks. Whoever owns the spectrum owns the fight. And that's why it's interesting to talk about. So what does it actually mean to dominate this environment? Not just tactically, but also strategically. What does it mean? And that is exactly what we're trying to unpack today. And I couldn't ask for a better guest. Mike Cocke is the Senior Director of Business Development within Self-Protection Systems at Terma. And before that, he spent nearly 24 years in the United States Air Force at the sharp edge of electronic warfare. So just to go through just a handful of bullets from a very extensive CV, Mike commanded the 350th Spectrum Warfare Group, which was five squadrons, more than 850 personnel, driving spectrum superiority. He led the 68th Electronic Warfare Squadron. He was the deputy commander of the 53rd Electronic Warfare Group. He ran an advanced and special access program at the Air Force Global Strike Command. He was the flight commander at the 96th Bomb Squadron, which was also, I believe, when you were flying the B-52. And on top of that, he also instructed at the US Air Force Weapons School. So we're talking operational stuff, we're talking strategic, we're talking requirements, reprogramming, capability development, the full spectrum, quite literally. So today we are going deep, and I just want to say welcome to you, Mike.
Mikkel, thank you very much. It's a great opportunity. It's really nice to be able to talk spectrum warfare. It is definitely a niche area of military operations that most people outside the military have no idea that it exists, and many inside the military don't really know a lot about how it operates. So it's a great opportunity to talk about it and kind of shine some light on the subject.
I think it's really interesting you say niche piece of warfare, because that's like, I remember I had an interview with some of the space people, and they said, well, you know, space and satellites and protecting cybersecurity on satellites, it's basically a niche thing. But the thing is, yes, it's niche, but if it goes, if it breaks, like everything falls apart. And I kind of have the same feeling here. You say it's niche, but if it falls apart, everything falls apart. Is that true?
Yeah, no, absolutely. In fact, I really liked your intro. You did a very good job of encapsulating how foundational electromagnetic superiority is to modern warfighting. When I say it's a niche, what I mean is that most people don't have a knowledge of it. When you watch, when you see military operations on TV or in the news, you see tanks, you see airplanes, you see ships, and like you said in the intro, this is the invisible side of it that you can't see, but it is the foundation for military operations going forward. It's absolutely essential.
Yeah, I mean the what you see, what part of it you see, you may have like one clip of that radar the round radar screen that beeps. Right?
Yep.
That's kind of what you see, but it's just so much more than that. And I think actually it's a good place to start. Maybe you can take us through something that you've experienced in your career that really demonstrates what electronic warfare, or EW, is for people outside the, Air Force, basically.
Sure, absolutely. So I can give you, I guess, a niche of a niche, because electronic warfare is actually somewhat broad. There's different types of it. There's electronics intelligence, where you want to learn about enemy radar frequencies and how they communicate with each other, and you want to gather intelligence data. I came out of self-protection electronic warfare field, so I would fly on the B-52 and I would run the self-protection systems, the radar jammers, so that when the radar was painting our aircraft, I would put out electromagnetic noise so that they couldn't find us or shoot at us. And I had all the sensors and expendables and decoys to decoy missiles and things like that. So I was a self-protect electronic warfare officer to make sure that my airplane was not shot down while we were going to hit our target and come back out again. So that was my role, which is a niche within electronic warfare writ large. And so most of my personal stories as it relates to employing electronic warfare are related to enabling something else. In this case, my airplane to get to the target and then hopefully get back home again at the end of it. And so you go through electronic warfare training and you learn all the signals and radars and how they work. And then at some point in everybody's career, you're on the jet for the first time when you see it work. And it's like a light switch moment where all of a sudden it becomes clear and you understand what you're doing. I had a couple of incidents where that became really evident to me. So I was on a flight once in the B-52, and we were typically, when we fly around in the United States, we have our training loads in our electronic warfare gear. So it'll sense the environment, but it's really not transmitting the good, high quality jamming stuff, because we save that for war. We don't just use that day to day. And so we were, anyway, on this particular mission, we were out and we had our war tapes loaded. So we were configured with a wartime configuration on our countermeasures. And a real adversary radar came up, and my system identified it and countered it. And it was, what was most amazing is I saw the radar signal come up on my scope. I saw all my sensors pick it up, and immediately the system put a jamming package on it. I saw the jamming package cover the signal, and then immediately walk it off the scope in under a second, and it was just gone. And then the signal would come back up, and they would try to find me again, and it would walk it right off again. And so for about a half a dozen times, they tried to lock us up with this enemy radar, and the jamming system was so good that they couldn't lock the aircraft, and they couldn't prosecute an engagement against us. And that's significant because, the B-52 is a huge airplane. It is a flying radar reflector. You don't hide it. It's not stealthy at all.
It's a bomber, right? It's a bomber.
It's a huge 8-engine bomber. 1952 it first flew, way before anything stealth. And so it is not hard to find and shoot down.
Not exactly third generation aircraft.
Right. And so, but they couldn't shoot it down. They couldn't lock it up. They couldn't prosecute an engagement because the jamming was so good that every time their radar took a look at us, our jamming system just walked that signal right off of the target.
What would have happened if your systems didn't work?
Well, so as soon as that radar painted the aircraft, it would have locked us up. It would have handed off a track to a missile, and it would have fired a missile at the aircraft. That's the normal progression for that. So this was a TTR, a target tracking radar, which tracks the aircraft, and it would have passed it off to a missile, and it would have fired. But the system, the electronic warfare system, meant that radar could not find out where we are. And there's numerous stories of that.
How is your pulse at this moment?
So honestly, the jamming happened, the countermeasures happened so fast that by the time I realized that I should be scared, it was already dealt with. The signal pops up, I identify it as a threat, and before you can even start to do anything, the jamming system has put out a jamming package to cover the signal and walked it off the scope. And so it happens so quickly that I didn't even really have time to process the fact that that's a bad guy radar, and this is not a great situation, and it was completely countered. So
it's not one of those moments that people talk about where everything you see turns into black and white. So your cognitive power is concentrated on the actual threat and not the color of the screen or whatever it is.
Yeah. So there are moments of in aviation, we call it time dilation, where time seems to slow down because there's so many things happening and your brain is processing so fast that it just seems like time has slowed down. So that is the case, yes, but there wasn't any, I don't know, any anxiety, any fear, any concern. It was just, there's a lot going on and I've got to do a lot of things. And I was just very focused on handling the situation. So it wasn't until afterwards you realize, wow, that was interesting. That was a significant event and everything worked just the way it was supposed to.
Well, that is very good. You said this is a niche within a niche. Yep. If we step one step back or up the ladder or into a more strategic place, why is electronic warfare, and I know that you also call it spectrum warfare, why is that important from a more strategic or maybe tactical point of view? And what's the difference between the two?
I guess I should say this up front. So I was trained as an electronic warfare officer, and so I call it electronic warfare. And that's what I'm familiar with. And so probably about 5 years ago, the Air Force changed the term to spectrum warfare, and they did it for a good reason. But I struggle with that because I'm an EWO. I grew up an EWO. Historically, it's been EWO, and so the change in terms is hard for me to come to grips with. But I do think it was the right decision. So electronic warfare was largely focused on countering adversary radar systems. And that's because we want to be able to get our planes in there without being detected, or we don't want to get shot down by surface-to-air missiles. And so electronic warfare historically has been focused on countering, from the Air Force perspective, has been focused on countering surface-to-air missiles. The realization recently is that it's not just enemy radar systems. It's communication. There's electro-optical. There's infrared. There's UV. There's lasers. There's all kinds of other sensors that are being used now to deny access to military forces. And so it's more broad than just the historic radar. And so in an attempt to capture the fact that it's a more broad application of the electromagnetic spectrum beyond just radar, they changed the term from electronic warfare or electromagnetic warfare. They changed it to spectrum warfare. I think it's the right decision, but I struggle with it because I'm an EWO, and that's just how I grew up.
And now, what does it mean to be a dominant in this space? And is it even? What does it mean? I think that's a good place.
That's a great question. Among other things, I'm a fan of history, and I tend to perceive the world through historical lenses. And so, when I look at what's going on in the world right now, I see a parallel. So Ukraine's a great example, but I see a parallel between what was going on in World War I and what's going on in Ukraine right now. And so when you look at the early 20th century, the airplane was a brand new thing. And so in the early 20th century, there were several air power theorists that decided that, aviation's going to change the world. It's going to revitalize everything in new and interesting ways. Italy had Duhay, the UK had Trenchard, and over on our side of the pond, we had a guy named Billy Mitchell. And as soon as I say the name Billy Mitchell, the heart of every airman skips a beat. He's like one of the fathers of the Air Force. Like historically, people look back at him as one of the guys that laid out the path for the U.S. Air Force. So Billy Mitchell was a fairly senior officer that went to World War I, and he was appalled at the carnage in the trenches. Massive battles, tens of thousands of lives lost in a battle to gain a few hundred yards of territory. And when he looked at aviation, he saw the airplane as the way of overcoming that. No longer did you have to fight through an enemy's army to get to their factories, to get to their leadership, to get to their industry. You could go right over their army and attack their centers of power directly using the airplane. And so in the 1920s, Billy Mitchell looked into the future, and he realized that wars were going to be won or lost in the air going forward. And so a part of that, a part of being able to fight a war in the air is air superiority. And when you look at what's going on in the Ukraine right now, neither side has air superiority. And because they don't have air superiority, they can't get the initiative on the ground to prosecute the war, and neither side can achieve any of their aims, and it's become a stalemate, much like World War I. Now, the reason neither side can attain air superiority is because neither side has spectrum superiority. Their radars are not working because of jamming. Their communications are denied and degraded. Their GPS signals are being interfered with. And so in the vicinity of the battle, neither side can gain the advantage in the air, which means they can't gain the advantage on the ground, and you end up back in that World War I stalemate.
Yeah, and I think prior to us starting the recording, last time we spoke, it occurred to me, and I think it's a very layman thing that occurred to me, but it occurred to me that all of this jamming, it completely shuts down everything that we take for granted. Just the fact that I can use Google Maps to see which route to, when I drive to work, which is the one with the less queue, and like all of this shuts down. Can you try and describe the situation that the Ukrainians are in, but also I guess the Russians are in, because they're in the same situation, the people on the ground? Mm-hmm. What is their reality? How easy is it for them to communicate, to know where the adversaries are, to, all this?
Yeah, so it is, in many ways, it is exactly like you say. The systems that they're used to using, their GPS, their radios and things, oftentimes do not work at all. They can't communicate with higher echelons. So they're left isolated and conducting battle without that overall coordination and efficiency you gain by centralized control, right? But the other side of it is also true, that sometimes when their things work and they're able to transmit, that transmission can highlight their position, and then they can fall under fire because of the fact that they are transmitting. And so there's a combination of nothing's working, but if it does work, then I'm sending out an electromagnetic signal that can be detected, yourself. And I can highlight my position. And so it's bad in both ways. And so what this has tended to drive is combat more along the lines of World War I. Your commander in the field is just isolated from his headquarters. He's making the best decisions that he can make, but without access to all of the information that they're oftentimes used to having because of satellite and overhead imagery and communications with other units. And so it's devolved back into Stone Age is the wrong term, but more along those lines, like a more primitive type of warfare.
Yeah, I recently saw, and it's not because real war is much more hardcore than making it into a Hollywood movie. But I recently saw the First World War movie, which is like in first person perspective all the way. And that is exactly what we're talking about here. Like he needs to get to another group of people and they can't reach them by radio. Yes.
Yeah, very, very much like that. And that's a great analogy too, because the two soldiers that are sent out on that mission, like once they're given their orders and they go, that they don't get updates on the way. There's no, just go do your mission and figure it out. And you don't get updates from higher headquarters. You don't get new maps. You don't get new information about what the enemy is doing. You have to figure it out as you go, just based on the information that you have at hand. And that's very similar to what's going on right now in the Ukraine.
That's really crazy to think about. I think a lot of people don't realize that it's crazy for me. It's really. How do you, if we turn back to electronic warfare, how has this area developed over time, and what is it today compared to before?
Yeah, so that's really a great question, and that starts to pry apart, I guess why it's a niche. So electronic warfare really had its birth in the Second World War, when the first massive application of radar, right? So the British had it during the Battle of Britain, and they were able to position their fighter force to defend against the German aircraft. The Germans started to develop radar, and then both sides started to develop countermeasures for radar. Strips of aluminum foil they would throw out that would look like an aircraft. Transmissions jammers that would transmit on the same frequencies to just fill up their scopes with snow and things like that. And largely the countermeasures, the electronic warfare countermeasures, were done to hide aircraft and where they're operating, so that the Germans or the British and Americans couldn't position their fighters to defend properly. And that was the creation of it in World War II, and it kind of stayed that way for a while. It wasn't until the very late 1950s that electronic warfare really started being taken seriously as a requirement for military operations. So different people have different dates that are important to them for various reasons. I'm an electronic warfare officer, so October 7th, 1959 is an important date for me. That was the date of the first operational shoot down of an aircraft by a surface air missile. So the People's Republic of China had a Soviet SA-2 surface air missile system, and it shot down a Taiwanese RB-57 that was on a reconnaissance mission over China. So the Taiwanese were flying a reconnaissance mission. The Chinese shot down that aircraft in October 1959, and that was the first time that a surface air missile shot down an aircraft. To me, that that marks the turning point of electronic warfare, where the threat of radar has become immediate, and it can now effectively, limit your ability to attain air superiority and push you back towards that World War I stalemate. For the U.S., though, we didn't really pay attention when that happened. We lost more and more aircraft. There was a famous May 1st, 1960, the U-2 was shot down over Sverdlovsk in the Soviet Union, and the pilot, Francis Gary Powers, was captured by the Soviets and put on trial as a spy. If you've seen the recent Tom Hanks movie Bridge of Spies, it tells that story about that U-2 shoot down. We had another U-2 shot down over Cuba during the Cuban Missile Crisis, but really it was Vietnam when we started losing aircraft to surface-to-air missiles, and it was limiting our ability to go prosecute that air war that the U.S. finally woke up and said, we need to do something about this.
These aircraft, did they not carry any countermeasures to this jamming onto the missiles?
No, not at the time. Mostly because it wasn't seen as necessary, and we saw at the time that radar was there to detect and warn the enemy of your approach, but that it couldn't really do anything to stop you. The radar-guided missiles is what changed that. And so at the time, the aircraft, they didn't even have a sensor to let them know that the radar was looking at them. So there was no jamming countermeasures. There was no chaff or expendables that you could put out to decoy a missile, and there was no warning in the cockpit that you were being shot at. And so once it was the summer of 1965 in July that the first F-4 Phantom was shot down by a surface-to-air missile, and that's what caused the Air Force to wake up and realize that we needed to do something to conduct, combat operations in the spectrum to enable us to go do other things. And so then from that point, the Air Force built out all of the architecture that you saw in like Desert Storm. We have advanced jamming platforms, we have other countermeasures, we have stealth aircraft, we have a lot of things designed to suppress that radar threat, so we can go in and conduct our military operations.
And I want to fast forward a little bit, because back then it was mainly hardware-based jamming equipment. Yes. It was hardware-based stuff. And now we're talking about software-defined radio. We're talking about software-defined everything. What does that mean? One thing is seen from the aircraft. It makes things difficult at the aircraft. But what does it mean, again, if we take one step up the ladder and say from a tactical point of view, but also maybe a strategic point of view, what does that mean that we are now talking software rather than hardware?
Yeah. So Mikkel, that is the heart of the struggle that's going on right now. I mean, that right there, that is the key element of the change that's going on in a part of the struggle. So like you said, 1960s, these threats are being made. They're all hardware based. You can't really change them very much. Whatever rolls out of the factory is what you've got. And so historically, an adversary system would have a handful of operating modes and like 3 or 4 war reserve modes. Like when the war happens, you turn the switch over to the war reserve mode, and you've got about 2 or 3 of those, different frequencies, different scan characteristics. But once the other side knows what those are, you can counter them, and that's it. There's no changes. But now with software-defined radios, with multifunction apertures, you can change the characteristics of a radar system with a simple software update. And so it's no longer hardware limited. So those 2, 3, or 4 war reserve modes that you have to worry about. So night 1 of a big war, they're going to go to war reserve mode number 1. But by night 5, all of their tricks and your aircraft are completely protected. That's no longer the case. Night 5, they can do another software update and have completely different frequencies, completely different scan characteristics. And so it complicates our ability to counter it. Like we used to know that if a major war kicked off, that night 1 is going to be pretty bad because they're going to go into the war reserve modes, but by night 3 or 4 we're going to be okay, and that guarantee is no longer there because of the changes to the systems that are operating in the environment. And so that has all kinds of implications because all of our acquisition structure in the U.S. is designed to counter fairly slow moving adversaries that iteratively improve, and we can iteratively improve as well to counter them. When they have the ability to do massive updates and changes rapidly and quickly, our entire process for acquiring new technology is designed to counter an industrial grade adversary, not an information age one. And so we have to update all of that.
I think we need to dig into that a little bit, because what does this exactly mean? So you say the infrastructure, the acquisition infrastructure architecture. What do you mean by that?
Sure. So when I say that, I'm talking about the way in which and again, I'm an American, so I talk from the American point of view for how the U.S. military acquires military hardware, and so pretty much the way in which the U.S. began acquiring military things was really defined in World War II during the massive expansion, and then it's kind of been developed since then. But that was the genesis of it. The U.S. is very cognizant of the fact that it's making its taxpayers buy all of this military technology, and so they very much want they want to make sure that whatever they're acquiring is good value for money, and so they've developed an architecture to develop slowly, to test everything very robustly, to make sure it's working exactly the way it's supposed to, so that by the time it gets fielded, we are very confident in how it's going to operate and how it's going to handle the environment. And that's a good thing. I mean, it was designed that way for a very good reason, to make sure that our military hardware is effective. It does exactly what it's designed to do as good as possible.
Basically, to make sure that when you're sitting in that B-52 and your lamps are flashing, it works. That's what we're talking about here.
Yes. And it works the first time. The first time it encounters the enemy, it does exactly what it's supposed to do, and then it functions. And so our entire way of acquiring military hardware was designed with that in mind. We want to make sure that it is high quality as it fields. And that's, like I said, that's great for what it is, but it's slow. And with the environment changing the way that it is, it's not fast enough to keep pace with the introduction of new systems.
And I know that, proven technology, the word proven, it's been a buzzword in military operations, but also in critical infrastructure protection. All of these security and safety measures that we have across domains, across industries, to buy proven technology, basically because no one wants to be the guinea pig, right? Are you suggesting that we should stop putting so much emphasis on the fact that things should be proven or fielded beforehand, and then, well, I'm sorry to kind of maybe paraphrase you, but to take more chances?
So not necessarily. So in all of this, in anything that the military is purchasing, there's always risk involved with every acquisition program. And so what I'm saying is we need to decide where we're going to take risk. The decision historically has been made that we are not going to take risk in the development of the new thing. We're going to make sure that it works. We're going to test it robustly. We're going to make sure that on day one that it enters the field, that it's ready to go. There will be no risk there. But the risk that you buy when you go down that path is the risk that it's going to take years and years and years and years, and is not going to be developed and fielded for a very long time. I mean, look at the F-35. That thing has been under development for decades, and it's still just now starting to hit operational frontline with forces. And so the process was set up to robustly test all that, and that's fine. But you end up buying the risk in the timeline that it takes to get that into the field. And so my argument is, perhaps the time risk is more important than you think, and you should take risks somewhere else, in the development, maybe in the testing, in how robust something is, in order to get it into the field faster. Because I believe the rate of change in the operational environment caused by software-defined radios and all of these rapidly evolving threats, the time risk is too high to accept now.
I think you put it quite in quite nice words last time we spoke. You said risk has been about fielding something too soon. Now the risk is fielding something too late.
Yes. Yep.
And I think
the words that we often use in the Air Force is perfect is the enemy of good enough. And if we can get good enough into the field, we should stop striving for the perfect thing. Let's get good enough out there now, and then we'll keep iterating on good enough, and we'll make it better as we have to. But we need to stop striving for perfection right out of the gate.
Now, you mentioned the F-35, and the F-35 is what you would call a fifth generation warfighter. So, and the generational bit is about how stealth it is, how good the sensors are, what kind of sensors that's on it, and all that kind of thing. we are now already looking into Generation 6 platforms. Can you maybe elaborate that a little bit? What does that mean?
So historically, and this will take a step back just to look at kind of, again, back to fundamental electronic warfare. We used to always talk in terms of kill chains. And so that's the way that the enemy will try to shoot you down. And so there's an early warning radar, and they will pass a track to an acquisition radar. And that acquisition radar will pass a track to a target tracking radar. And that target tracking radar will pass a track to a missile, and that missile is going to shoot you down. And so the way that you don't get shot down is you break that chain in some point. You deny them that
any
early
place,
warning.
and that's
Anywhere, and they can't shoot you down. And so that was the kill chain. And so what we found in the last probably 5 to 10 years is that the kill chain analysis is no longer viable or no longer valid in the modern battlefield, that they have what we've been calling kill webs. So that's where multiple radars can pass tracks to multiple radars. And so and it's all kind of networked together into a mesh. And so you can sever one link, but there's so many other ways to get that targeting information to that threat system to shoot you down that you can't sever all of them. So it's gone from a kill chain into a kill web. And so part of what six. I'm sorry. Go ahead.
That also moves the issue from the operational from the platform, basically from the platform itself. It moves it up the ladder up to a tactical level, because now the single aircraft can't really do anything about it. You can't shoot down one radar and then hope for the best. It's not going to work anymore.
Right, and so that's part of the problem that 6th Gen is trying to get after by essentially networking all their aircraft together to also be this intermeshed capability to strike multiple things at once, to self-protect each other, to identify when one is being targeted, and then everybody else on the network can engage to protect it. And so that's the approach for 6th Gen. It takes all the advantages of 5th Gen and then networks it together into more of a kill web structure.
This is so fascinating. I at the moment, I'm leaning very much into all that's happening on AI, and I can't but see the similarities. That it's the cat and mouse kind of problem that you learn one new technology and then you think you're good, and then the next month that technology is already outdated by a year. It feels like, right? So, and it feels the same way. It's you always have to be that cat and mouse position where you want to be, well, depending on the situation, you want to be either the cat or the mouse, right? So,
and in fact, that analogy is that exact analogy, the cat and mouse, is exactly how they describe the history of electronic warfare. Like if you read the history books about electronic warfare, it's measure, countermeasure, 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 and that's exactly how it's been developing. And then with AI and machine learning, it's accelerating even faster because they can process and identify new things even quicker.
I mean, even just sending out signals on different wavelengths, they could have an AI just change the frequency all the time. So you would never be able to counter it or do anything about it. You would have to do it in another way, right? And I'm thinking it's the same story when we were talking to Saman Kajuria as well, who's talking about cybersecurity and quantum security. It's also the cat and mouse always. And it's just but I guess that's how it is, because both sides need to upgrade their way of protecting themselves gradually, and they need to match each other all the time.
Yep.
That is
and I do think going forward that AI is going to become the key enabler for electronic warfare, spectrum warfare, as we say these days, for spectrum warfare going forward. I think AI is going to be the driving force. So I'm an EWO. I think I'm a dinosaur. Like, I don't think there's going to be very many more EWOs made. I think the future EWOs are going to be an AI algorithm sitting in a black box on an aircraft making the decisions. I mean, I had to go through about 9 months of training to understand radars and how they operate and how to counter them. And at the end of that, like I remember while I was at electronic warfare school, I remember driving home, after a day of learning radar stuff. And I was playing the radio in my car. And this is in the days before satellite radio, so you had static and stuff like that. And as a part of EWO school, they make you listen to radar signals, and you can identify what radars are by what they sound like. I can identify, that's based on the scan pattern. That's an early warning radar, or that's a height finder. That's a target tracking radar.
Really?
And yeah. And so I can tell
you
different
hear
radars.
The difference.
Yes,
with audio.
With audio.
Wow.
But driving home after class, there was static on the radio, and I could hear in that radio static. I'm like, that sounds like an F4 Phantom radar. Like I can hear in the crackle the character, right? And that was me after months of getting constantly trained on it. And AI can do that as well. It can be taught to listen to the radar environment. It can be taught that, hey, when it sounds like this, it's probably a target tracking radar. And if it's a target tracking radar, it's probably vulnerable to one of these countermeasures. Why don't you try one of those? And so as much as AI on the other side is a problem with them modifying their radar signals, AI on our side is going to help us to process through that faster, to be smart, to have taken what took me 9 months to learn in a day or so, and then be able to apply that going forward.
And it's also, you learned it in 9 months, but if you had to teach someone else, that will take an additional 9 months.
Oh, yeah, absolutely.
Whereas if an AI learns it in, let's just say, 90 days,
yep,
all of the peer AIs, they will learn it instantly,
yep,
afterwards. So that whole time difference is definitely something that is going to be very interesting to follow. It's going to create a lot of problems, and it's also going to create a lot of possibilities, I'm sure. Mike, if our time is up, but if you had to draw out like one thing that the listener inside the Air Force or inside the European Air Force that is now building up, the whole European defense, what they're talking about. If you were to draw out one thing from our conversation that a professional within this field, they should really take away, what would that be?
I was pondering that actually as I was contemplating this discussion. I would say, again, because I'm a history guy, like I look back at history and none of this is new. I mean, the specifics of what we're dealing with is certainly a challenge, but the measure, countermeasure, cat and mouse, this has been going on for forever. It's a much more complicated problem that we're trying to solve, but I'm confident that we can solve it. The humanity, we have solved some very difficult problems in the past. We'll solve this one too. The tricky thing about this is the speed at which it's happening. But I know that we can, because I know that we have. And so I think overall it's a don't panic. We're smart, and we're going to get to where we need to go. And in the meantime, get back to the fundamentals of military operations, learn how to make decisions with incomplete information, take the initiative and follow the orders you've been given and execute as best as you can with the information you have at hand. And that has worked for thousands of years until the 20th century, when we suddenly had access to all the information. So, it can still work again.
I think that's a very good ending point. Sharpen your decision pencil so you're able to make decisions quickly based on, some call it gut feeling, but gut feeling is basically just a bad word for experience. And I've seen this pattern before. So yeah, I think you're absolutely right. And it's very interesting to talk to you. Mike Cocke, thank you so much for shedding light on this niche of niches, I would say. It was a real pleasure. Yeah, so thank you for joining.
Yes, Mikkel, thank you so much. Always enjoy talking electronic warfare, and it's been great getting to know you, and appreciate the opportunity.
Thank you. And of course, to the listener out there, I hope that you found this conversation interesting. And if you did, I'm sure that others will too. So please do help us share this episode with your peers, with the people who you think would be also interested in electronic warfare or in modern warfare in general, and what technologies that involves. So please do share it with a friend or a colleague or whoever you think. If you have any questions, for Mike, if you have any questions for me or the team, send us an email at podcast@terma.com. That was podcast@terma.com. You can also, if you have any topics that you want us to talk about, or any people that you think we should talk to, let us know that way as well. I think all I have left to say now is thank you so much for listening.